In a glass of water, add about 1 teaspoon of oil. As you can see, the oil started to form a layer on top of the water and did not mix at all. And then we will add 1 teaspoon of soap in the mixture of oil and water. Upon adding the dishwashing liquid into the mixture of the oil and water mix together. Pour the milk into a dish. And then put some drops of food coloring into different parts of the milk far away from each other. Squirt a little soap into a cotton buds and then place it soapy downside in the dish. And as you can see, food coloring started to swirl around the cotton buds.
So for the activity 3, how does fat keep us skinner? Background. Anyone who has ever dieted knows how difficult it can be to lose weight. New research shows that it may not be your fault. Humans are hardwired to store energy as fat. For our ancestors who were often uncertain about when their next meal would come, storing fat was a beneficial adaptation that helped them survive famine. Today, most of us are fortunate enough to have an abundant food supply, and storing excess fat can cause problems. Almost all the food we consume is in excess of what we need for energy. Whether it comes as fat, protein, or carbohydrate, is converted to fat and stored. But since we can also store carbohydrates as glycogen, the body's other energy storage molecule, why does the body go through the effort of converting most carbohydrates to fat? Fat has about 9 calories per gram. Glycogen has 4. This difference means that using fat, our bodies can store more energy. And in less space, what would happen? So the question is, what would happen if the body stored energy as glycogen instead of fat? So my answer is, if the body stored energy as glycogen instead of fat, we would need much more space to store the same amount of energy. This would make us bulkier and heavier, which would have negative health consequences. Additionally, since glycogen is stored in the muscles and liver, there would be a limit to how much energy we could store. Fat, on the other hand, can be stored in the adipose tissue throughout the body, giving up as a virtually limitless storage capacity. Overall, while storing exists, that fat can have negative consequences from an evolutionary standpoint. It makes sense as a way for our bodies to efficiently store energy for times of scarcity. So for the table, the instructions using the conversions and data provided, calculate how heavy a 145 person pound with a healthy percentage of body fat would be if all of their fat was replaced by glycogen. So first, we need to determine the weight of fat in a 145-pound person with a healthy percentage of body fat. Let's assume a healthy percentage of body fat is around 20%. So 145 pounds times 0.20 equals 29 pounds of fat. So next, we need to convert the 29 pounds of fat into grams. 29 pounds times 454 grams and pound equals 13,166 grams of fat. Since each gram of glycogen only contains 4 calories, compared to a 9 calories of fat. We need to determine how many grams of glycogen would be needed to store the same amount of energy. So 13,166 grams of fat times 4 calories gram and 9 calories gram equals 5,844 grams of glycogen. So since glycogen holds twice its weight in water, we need to add the weight of water to the weight of the glycogen. 5,844 grams of glycogen times 3 equals 7,532 grams. So finally, we need to convert the weight in grams back into pounds. So 17,532 grams divided by 454 grams pound equals 38.6. So therefore, if all of the fat in a 145 pound person with a healthy percentage of body fat was replaced with glycogen, they would weigh an additional 38.6 pounds due to the water weight associated with the glycogen. Their new weight would be approximately 183.6 pounds.